Welcome to a new video in my home automation series, and today I want to show you this energy dashboard that I made for my home, because I really liked how you can have this very simple dashboard which shows you how the electricity flows when you have like a Tesla system, especially if it's a more complicated one with a Powerwall and a car charging. And I don't really have such a complicated system because I just have solar panels. I don't have a car or a battery system, but still it was a good fun just to integrate all these measurements and then, you know, also have these animated arrows to show where the energy is flowing. So what you can see on the screen, because it's Hungarian, is on the left you can see my three different solar inverters. So you can see the actual generation for each of them. And then the fourth number on the bottom is the kilowatt hour generated today. And then they feed into the house, which is in the middle. And then you have the three phases which are going out to the grid. And I can see whether the electricity is flowing in or out. And as you can see, the blue arrows mean that electricity is flowing out. So I'm supplying electricity to the grid. The red one is the other way around. So I'm buying electricity from the grid. And on the top you see again two numbers, and those are my current balance, how much excess energy I have generated since my annual meter reading back in January. So this is all the energy that I can use throughout the autumn and then within the winter in order to, you know, net off to zero. So if I manage to do that, I don't need to pay electricity for this year. If I use more, obviously I have to pay that. And if I use less, then I will get some money back, which I don't really want to. So the goal is just to use all this electricity, and we'll see how it goes. And I think within the video you can see that in some cases the electricity is going to change. So I wanted to simulate some excess consumption. So I was turning the kettle on and the microwave on. But other than that, it's pretty much in the morning. So it was an overcast day. Not much is happening at home, so I'm not using an awful lot of energy. But before we go into the details, I wanted to show you how the whole system looks like. And it is quite a convoluted system, but well, I was just basically integrating whatever I have. And this time I prepared a PowerPoint presentation for you. It's only going to be one slide. So it all starts with the data inputs. So first of all, I have a solar inverter, so solar panels and an inverter. And I have a VMOS D1 Mini based small board, which is reading the data of this inverter using over Modbus RTU, so Modbus serial. And I made a whole, I think like a whole series of video how I built this project. And of course it is available on GitHub and everything. And well, actually I have three different inverters with, you know, three sets of solar panels. For a specific reason that I again detailed in a separate video. So actually there are like three of these VMOS units reading of the one inverter each. And then this information goes into my main server, which is like a small Intel based server that is running loads of things, and amongst one of the things which is running is a Node-RED with an MQTT broker. So the information goes to this server via MQTT. So that's basically feeding in all the generation information and everything. And since we are talking about data inputs, I also have a Shelly 3 EM that is hooked up to the three incoming phases, which is, I mean, it's not right after the main breaker and the what is it, the meter, but it is pretty much seeing the overall consumption of the house. So that's basically tells me if I'm generating more than I'm using, or it's the other way around. So that also goes into Node-RED using MQTT. So obviously most of the processing happens in Node-RED. And then I also have Influx DB, and I just push, well, pretty much everything into Influx DB. And I think I already mentioned that in the previous video, how I process the data which is coming in. I mean, I think I talked about it when I was going through this project here to reading the inverter, how I pass this information to Influx DB. And I also have a Grafana dashboard on all this information, which is not really important for this particular project, but I thought I'd mention it. And the other thing which I do in this Influx DB, again, there is a separate video on that, is I also capture all my monthly meter readings. So this is how I know what was the last build reading, and then from that I can calculate my, how much I'm ahead or behind in terms of generation for the year. And so the first thing that I did, because I knew that I wanted to display this information on the touch panel as well, I sent this information from Influx DB back to Node-RED using MQTT. I could have done it in the other way, but actually that was an interesting new feature, how you can create a task in Influx DB to send data over MQTT. And it could be useful for other scenarios as well. So that is yet another information which comes back from Influx DB. And then once this is all in MQTT, in Node-RED and also in MQTT, I need to pass this information to my PLC, which is a SIOP PCD. And so in that, I created a couple of registers to hold all this information. So, how much I generated for each inverters, what is the today's total consumption, so that's 4, and I have 3 more data for the 3 phases, which you could see on the screen, and then 2 more registers for the 2 balances that you could see on the top of the screen. So those are 4 registers, and I just update these holding registers using Modbus TCP. And then finally, the display part of it is a Riectech HMI, so it's a 7-inch touch panel. And that again communicates to the PLC using Modbus TCP. So I've just specified what are these addresses that it needs to read and how it should display on the screen, like whether it's a signed value or unsigned value, whether it has any decimal places or not. But that's pretty much it. And of course, the other option would have been, if I don't have a PLC, is I could have created all these registers inside the PLC. Inside the HMI, so the touch screen, and I could also update that straight from MQTT, straight from Node-RED using Modbus TCP, but I have 3 different touch panels in my home, so it is much easier to put the data up into the PLC, so all of the touch panels can just read it from a central place, rather than updating all 3 of them at the same time, or updating all 3 of them separately from Node-RED. So I thought this is probably a cleaner topology, and I would be using the PLC for all the other information that I display on the touch panel anyway. So yeah, reading a couple of more registers is not going to make a huge difference. So this is the whole setup overall. I'm recording this part of the video in the evening, so I can't really show you too much on the inverter side in MQTT because while all the inverters are sleeping at the moment, there is no PV output. For some reason, I'm still getting data from one of the inverters, but not from the others. They just turn off, so there is no response on the Modbus line. I really don't know what's the difference between this one. I mean, they are pretty much the same. Well, more or less the same grow watt inverters. But anyway, so this is one where I usually get the data. And so you can see it looks like this. But again, I've talked about this extensively on my other videos. And actually I'm looking at the output power attribute, which tells me the actual generation. And also I'm looking at the energy today to see how much it was generated by that inverter. So which gets added up for all 3 of them, and that's what gets displayed on the screen. The other thing which I should be getting here are the 2 balance values which are coming back from the other thing which I should be getting here are the 2 balance values that are coming back from Influx DB. So let's head over to Influx. Oh, by the way, this is the Grafana dashboard, and these are the 2 balance values that I see, which I have here, and I wanted to show this information on the touch panel as well. So these are the figures that I think you could see 1999 and 2001, something like that. Obviously it gets rounded up here because Grafana already does a conversion from the kilowatt hours to megawatt hours, and then it just rounds to 2 decimal places. but it is around the same number. And if I go back to Influx DB, I want to show you how you get data from Influx back to Node-RED using MQTT, because I could just run a query in Node-RED and then schedule that query, like maybe run every hour and then get the data, but you can do the other way as well. And you head over tasks. I think I've talked about tasks in my older videos, but I have two more tasks that I've created. One is the send electricity balance and then send the electricity estimated balance, which is pretty much is the same query which is running behind these two boxes. So I'm not going to go into the details. Again, I talked about it in previous videos, but these are the two that calculate the balance in two different ways. So what I needed to do is actually create a task which runs the same query and then send the results over MQTT. So if I don't want to update. So if I do this and I do edit task, well, it's going to be a long query, but you can see the front of it is the usual one, so it is scheduled every hour. And then there is all this selection which happens, which generates all the values. And then at the end, there is an MQTT command. But in order to use that MQTT command, you have to add this to the top, which says import experimental/MQTT. And then what you have here is, normally you have a Flux query which ends with, either a join or a pivot or something like that. So anyway, it generates a table. And what you can do is you can use this command, which is the sort of the pipe MQTT2. And what it will do is it would send the results over to MQTT. So you can see here that I set up the broker and I set up the topic. So this is the topic the information is going to be sent to. You can specify the client ID. You can have a name for this. Obviously, you have the user ID and a password for your MQTT credentials. And then you can specify the value columns that needs to be sent, and then the tag columns. So obviously you would specify here whatever your last statement returns in a Flux query. And what I can do now is I can just run it. So we will see how it runs. And this runs every hour, but I just executed it now. And now you can see that the grovat/balance topic has appeared. And if I look at the results, it's not a JSON format, but you can see that it has the name of the query, which is, or the name of the query or the task, which is the balance. And then it has all the fields it has the and it has the tag, and then it has all the fields with field name equals value, and then it's separated by comma. So it's not a nice format which is easy to read. Well, it's not that difficult to read anyway. And yes, you have a timestamp at the end. So you can see again, balance that comes from the name, and that's the tag, and then space, and then you have the list of fields separated by a comma. And then if I would run the other one, that is going to be the same. So that's just called balance_est for estimate, but it pretty much does the same. So if I go back and the tasks, balance estimate, and if I edit task, so again, don't forget to add the import experimental/MQTT. It is a much longer selection. But if I scroll at the end, you can see that again, well, this ends up with a join statement as well. So I'm just joining two different queries. Anyway, you can just do it with a simple select and then MQTT2. And yeah, so the one thing I'm not really sure is maybe you have to play around with this, because in both of these cases, what I ended up having is a table stream which only has one single table. So obviously, when the data is sent, it is sent as a message with, no, actually it's a table with one single record. So that is easy to translate into an MQTT message, putting all the fields into the payload. I'm not really sure how it would work if the result of the Flux query is a complex it's a more complex data type, like if it has multiple lines or if it's a table stream. So yeah, you have to experiment with that, but probably you don't, I'm not sure if you really want to send a complex structure into MQTT, because again, it's a little bit hard to read. So I'm guessing it's best for sending one single value or maybe a couple of fields, because it's easier to process it at the other end. But you can see the same stuff. So it's called balance_est. Of course, it has different fields, so the text is going to be slightly different, but it's the same thing. It comes with a name and then the tags and then all the fields separated by comma. And to be honest, in terms of the task, that's pretty much it. So I quite like this MQTT functionality. It makes, again, integration really easy. And of course, that means that you could send this information to some other device as well, assuming that you can just, piece out the information that you want. It would be much better if I can just, configure this MQTT2 so it just sends one single value in the payload. So it can be sent to, a simpler device like an ESP, which doesn't need to just, piece out the data from this long string. But I don't think it's possible. So, okay, there are some limitations. And let's see how it looks like in the Node-RED side. So if I go to my Grovat tab, then, so if I go to my Grovat tab, what you can see is I have, two small pieces of flow, which reads the reads the balance and the balance_estimate, and I have a convert data function, which, as you can see, that's the format here. So I think what I do is I start splitting by space, because that's where this is where the tag is separated from the fields, and I'm always interested in the fields. And then I start splitting the second by commas, and then, at least here I know it's the first value that I'm interested in, so that's the balance. So I know how to get the data, but yeah, so I'm literally looking for this part and not anything else. Oh, actually, I realized that I left a comment for myself. So I split the data by comma and space, which means that the first one is going to be balance, and then this, and then that. And then I can, so I know it's always the third in the array, which is the balance that I'm interested in. And I'm going to split that by, the equal sign. And of course, it's the, the second value in the array is going to be the number that I'm looking for. And I just need to parse as an integer, because that's going to be an integer number. And then I'm pretty much doing the same for the balance estimate. And the only difference here is, it's also called balance here. No, actually, I think it's called different. I haven't updated this sample. But anyway, it's pretty much the same thing, but I know that I'm getting a float here, so I'm using parse float instead of parse integer. And then, of course, I can get negative values. And the Modbus, so the Node-RED Modbus module does not really, handle negative values. It just, writes whatever value into the Modbus register. So I take care of at least my PLC treats negative values with a first or the highest bit turned to 1. So this is how you calculate the negative value, basically. So I need to do that conversion, and I send it off to my PLC. So here, this is just a simple Modbus write, and I'm updating the single register. That's the name of the register. That's the PLC, and that's it. And for the float, I think it's pretty much the same. I'm just, again, doing a conversion for the decimal places. So no, I don't. No, that comes through as an integer as well. So I'm just doing the conversion from the negative number. Simple. And I have done these additions for, and this is where this is where I send the daily total to the PLC, so it's the same thing, just a different address. And whenever I'm getting update from the inverter, then I added this flow, which again converts the data. So I just get the data out from the output power property that comes over MQTT. And also I'm rounding it because yeah, I don't care about the decimals in the watt. And I send it onto PLC. So it's basically just getting all these pieces of data and doing some minor conversion and then setting it to the respective addresses in the PLC. And I could show you how I've done the configuration of the PLC as well, but I'm literally just using the PLC just to hold the information. So I just created a register in the program, and I'm not really doing anything with it. So there's nothing really special about that. So let me just show you how specifically it works in the Riectech Studio. Of course, if you're using different HMI, it's going to be a whole different story, but I think in most cases the concept is the same. So I just created these display elements, and of course, before doing that, I created all the data elements for the various registers. So I have a lot of these solar things. I think it's right at the end of the list, somewhere here. Yeah, so these are the various solar things. So I just configured them as, you know, this is coming over from the PLC using Modbus TCP. And again, I'm specified the same address that I've entered into Node-RED. And then I have these display elements, which is a simple numerical display. It displays, you know, whatever. It's either the balance or the wattage or the solar inverters, and I'm just playing around with the number format. So I know that this is coming without decimal places, so I just said 5 integer digits and 0 decimal points, and it's a 16-bit signed value because it can be negative as well. And for the others, it's yeah, it's 4 digits and a different address, but it's pretty much the same. It's just a numerical format. I haven't really done anything, you know, complex with this, like, you know, changing the colors if the value turns negative or positive. But the other thing I have done is these errors that you can see here, and these are actually well, animated GIFs behind them. So each of them is 30 by 30 pixels, and I have painstakingly created an image. I've drawn an arrow and I've moved that arrow 2 pixels, and I created like a 15 frame animation. And I mean, for all my paint work, I'm just using paint.net. It's a free paint tool in Windows. I don't know, maybe it works on other systems as well. But if you see, oh, I don't have it in my recent items anymore. I wonder if I can open it from here, if it remembers the path. Ah, I think it does. So, yeah, so it's a very low-tech way, but I basically created the 2 lines, and I created all the frames, and I just moved the arrow by 2 pixels, and I exported all the frames separately. And I just Googled how to generate an animated GIF, and I found this page where I could enter all these separate frames, and it would put an image together, an animated GIF. And it was so nice because it had a feature that once it generated the animation with the green arrows going right, I could say, please reverse the animation and change the hue to red. So with basically 2 clicks, I generated another animation where the red arrows go to the left. It was so easy. I still spent about like an hour generating all these frames, so it was a pain in the ass. But anyway, it worked. So I have all these lines. It's basically like, I think like 5 images of the same next to each other. And of course I made the images so they can seamlessly transition into each other. And there is this really cool feature in the Riectech Studio that I create another indicator light, and I assigned this graphics to it, which says that if in status 0, it's just going to display the static image with only the 2 lines, so no arrows moving. If it's status 1, it's the green arrows moving right, and if it's status 2, it's the red arrows moving left. And in the configuration, I could say that, for example, this one is looking at the phase 1 power going in and out, and so it's looking at the register for that. And if the value is 0, then that's status 0, so that's the stationary icon. If the value is less than 0, then it's the green arrows, because then I'm feeding into the grid. And if it's more than 0, then I'm using electricity, so it's the red arrows going into the house. And that's it. Very simple. And of course, I just had to copy it 5 times. And then the other one does exactly the same, but it's just using a different address. And on the left, well, obviously you don't feed data into, you don't feed electricity into the solar panel. So it just gets a little bit easier, because then it only uses status 0 and 1. But it's using the same graphic element, so that's 0 and 1. So it can be either stationary or static, or the green arrows going from the solar panels into the house. And it works pretty much the same as, you know, how you would see in one of these fancy dashboards. And I was really happy that it worked out that way. And yeah, I have my own dashboard. It would be great if I could add some more bits and pieces. So maybe if I would have, I don't know, like a car which I can charge, then I can have another something here which comes off, so I can measure that separately, and there will be another number and some other animations, or like a battery system. But I don't think I'm going to get any of those in the near future, so it's probably just going to stay like this. What probably I could do is maybe I can just do a calculation to add these 3 up and just have a total here, and then maybe I can have a total here as well. So in terms of total watts generated. So if I'm not really interested in the different phases, then I can look at that. Although sometimes it's interesting to see how they change. Like, I think in the beginning you have seen this one turning red, so that was when the kettle was on. And then I turned the microwave on, and the microwave is on phase 1. So then that phase started going over. So I was getting power on that phase, but then the other 2 was still feeding in. So yeah, it's just interesting to see. That's it. I think I've already put most of these project, or at least various parts of it, on GitHub and various other places, and I've described them in other videos. And there is not much else I can share about the Riectech project. I mean, this specific one I already show you how you can configure it if you happen to have the same HMI and the same settings. But if you need any of these other details, just let me know in the comment section, and I can just put it somewhere on GitHub, something specific in the flow which you didn't get by looking at the screen. But I think that will be all for today. Thanks for watching, and hopefully see you in the next video.